Okay, Geometry Standard 10.0 Test Review. We'll start with page 537, question number 12. What is the area of the figure at the right? Well, first of all, what kind of figure is this? If you'll notice that this line and this line are both perpendicular to this line here. Thus, these are parallel. So we have one pair of parallel lines and another set that is not. That would be a trapezoid. The area of a trapezoid is similar to that of a triangle. The area is equal to 1/2 is the basis times the height, but we have two bases, so the sum of the bases, 1/2 the sum of the bases times the height. Okay, so here is base 1, base 2, and the height, that would have to be the distance, the perpendicular distance between the two, so that would be 8. So that would be the height. Okay. So that's 1/2. Base 1 would be 14. Base 2, that would be 8. And the height would be 8 also. Remember, order of operations, do the inside first. So that's 1/2, 22 times 8. Half of 22 is 11, or you multiply across. You get 22 over 2. 22 divided by 2 is 11. Let's continue up here. So that would be 11 times 8. So that's 88, and these are centimeters. Centimeters times centimeters is centimeters squared. Okay, careful, when you add, we don't change exponents, so this would be centimeters. Centimeters gives us centimeters, but multiplying changes to square. Okay, page 538 in your book. We're going to find the area of each figure, but really we're only going to do one figure. We're going to do figure on number 23, ADJF. So that's ADJF. Let's outline that. ADJF. And if you'll see, we have a trapezoid again. This side is parallel to this side, and these are not parallel. One pair of parallel sides. So the area of a trapezoid is 1/2 base 1 plus base 2 times the height. Okay, to find the bases, we're going to write down the coordinate pairs here, the ordered pairs. F is at 2, 3, 3, 4. J is at 8, 8 over, and the same distance as this one, so that would be 4. A is at 1, 1. B, that would be at 10, 1. Notice this, when we go across this way, the X has changed, the Y does not. When we go up and down this way, well, we don't have it going directly across, but okay, so cleared that away. So I need the distance from here to here, that's 6 and 9, so that would be 15. And the distance from here to here, that's 9 and 9, that would be 18. So my diagonals, one of them, again we said this one and this one, that would be 15. And the second diagonal is 18. Okay, well, I don't want to work with decimals, so I'm going to do the commutative property of multiplication, and I'm going to multiply times the 18 and then times the 15. Half of 18 is 9 times 15, and 9 times 5 is 45, and I would carry my 4. 9 times 1 is 9, plus 4 is 3. 135, and that would be meters squared. Okay, moving on to the next one. Okay, this is on page 551. This is a triangle. The area of a triangle is 1/2 the base times the height. Again, here we have base and height. Anytime we see base and height, I want you to think perpendicular, okay? You got to think perpendicular. You want to know that these two, however they meet, wherever they're at, must be perpendicular. Okay? Base, height, height, base. Whichever way you want to look at it. Okay, let's look at our triangle. Well, here this line is perpendicular to this side. So we could use this side as our base and this side, this line here, as our height. So my base, I can see 6 and 6 is 12. However, I don't know this one. So what I'm going to do is I'm going to look and see. Notice that I have this triangle here. And this triangle is a right triangle. So this is 10 meters, and this is 6 meters. I know two sides of a right triangle, so I can use Pythagorean theorem. Pythagorean theorem, and so our legs are A and B. So we'll say this is A, I don't know B, and we'll call this C. So A is 6, so we'll say that's 6 squared plus B squared, and C is 10, so that'd be 10 squared, 36 plus B squared equals 100. Okay, and I subtract 36 from here minus 36 from here. B squared equals 64, and take the square root of both sides. B equals a positive or a negative 8. However, since we are dealing with distance, we don't have to worry about this being negative. It is just a positive 8. Now we can bring this over, and that's 8. Now I have my height. So the area of this triangle is 1/2, and then we have our base, which is 12, times our height, which is 8. Half of 12 is 6. 6 times 8 is 48. And this is squared meters squared. And I get 800. That's this area. Now I need to find the area of the triangle. Again, that's 1/2 the base times the height. I need this to be 90 degrees with each other. So look at this triangle, and I have 90 degrees right here. and we know each of these is 10, 10, 20, 30, 40, so that means this must be 10 also. And we already know that this is 16. So that's 1/2. And our base, we're going to call this 16. And our height, we'll call it 10. Half of 16, that would be 8, times 10 is 80. So I know this triangle is 80, and since these are the same, erase this triangle is 80, and the whole thing is 800. So let's finish this off. So that would be the area of the rectangle minus 2 times the area of the triangle, because I have 2 triangles. Multiply before I subtract. That's the order of operations, so it's 160. And we're left with, subtracting 800 minus 160, we are left with, what is that, 640. And again, this is feet, so this is feet squared. And that's it. Okay, write down any questions you may have, and in the first few minutes of class, I will answer the questions. Thank you.